Hello, this is Poike, and today I'm going to build a DIY ukulele kit by Harley Benton. It contains three main parts: the body, the neck, and the fingerboard. My copy has a neck that doesn't exactly fit on the body, so it's like wiggling a bit, and I need to sandpaper it, but we'll see more about that when I start painting. Also comes with a bridge and screws and tuner and a nut and a set of nylon strings. But I want to use a guitar pickup, as guitar pickups like this classic humbucker use magnets to react to metallic strings. I need metallic strings for my ukulele. Then I bought those titanium set from Dadario, which turned out being made of nylon, but with a fancy name. So okay, they are made of
a material that has an attractive translucent purple hue and a polished glass-like feel.
I can't use them on my project. Anyway, I also want to use one or two of those piezo pressure sensors that I'll stick somewhere inside the guitar body. There will be a simple mono jack socket and a switch to select the mic. Fast microphone, both ones, other one, nothing fancy there. I have the signal go through this LM386 and then that little PT2399 delay. They're easy to understand and connect, and everything is clearly labeled. On this LM386, I already removed the tiny onboard ports, and I will replace it with a big one. I just need to test and find the right value. I will also use the selector switches to choose which effect to connect or not. Then once everything is tested and working, I will decide where to implement the knobs and the switches, here on the body or here on the sides. Then I'll pick up the right caps, and I would like to put a mute switch somewhere. It's an arcade game, momentary switch, and here's how it works. There's a little box with a tiny momentary push button on top and a common log at the bottom. And those two logs on the side, one is normally open, which means not connected to the common log, and the other one being normally closed. Here we have the signal coming from the guitar mic, and we will send it to either of the logs using a switch that works like the other one but is a latch instead of momentary. Then the common log is connected to the output jack socket. I made a speaker, but you get the idea. So we have two positions from the blue switch. First position, signal goes through the normally open log, so it's not connected and there is no sound. But once I press this little button, I can finally hear how good I am at playing ukulele. Other position, the signal goes through, but whenever I press the button, it is cut and the uke is mute. Here's an example with an LED. Always on, but when I press the button, it turns off. If I change the position of the switch, the LED is off, but is lit back on as I press the button. This tiny LM386 board used as a kind of distortion of a drive with a tiny pot reset with a screwdriver. I'm gonna use and abuse it by tweaking parameters more than it's supposed to be. Use a larger potentiometer I can play with easily. Same for the PT2399 board. Although I need to remove this small pot and solder another one, it's even made for adding a potentiometer. Once again, everything is labeled. I also want to select different possibilities for the effects. Signal going through delay or distortion, or both, or none, that's like a bypass, or distortion and then into the delay. That makes 5 possibilities. We have different sources to connect: the direct signal from the microphones, the output from the delay board, and the output from the LM386. So that's 1, 2, 3 connections. For that, we use a rotary selector.
within the stereo.
While the paint is drying, we're gonna get deeper into the FX selector. This green wire is the signal from the microphone, which will send to the LM386 board used as a distortion stage, or this PT2399 echo delay board, or both of them. Or we send the dry signal directly to the output jack. This will be done using a rotary selector, and here is how it works. This selector has 3 inner legs and 12 outer legs. Those legs are labeled 1 to 12, but for a better understanding, we will use 1 to 4 3 times. Because this is indeed a group of 3 identical selectors linked to each other. Well, let me explain it better. When the knob is in the first position, all 3 inner legs are connected to their own first outer leg. But the outer legs are not connected, they are not linked to each other. When we switch to the second position, each inner leg is connected to the second outer leg. And it's the same for third and fourth position. Let's draw the selector in a different way. Here is the inner leg, and there are the 4 dedicated outer legs. We have a second and a third one. I built a model of that selector to show you better. This black lever selects which legs is to be connected, like the knob on the actual selector. Now we have our main output, the jack socket of the guitar, the delay board with its own input where we will send the signal to be processed, and its own output. Then the distortion board, also with an input and an output. The blue pins on the left represent the inner legs of the selector. The first one, A, will receive the direct signal from the mic. The B leg will be connected to the delay's output, and the last one, C, gets the distortion board's output. For clarity, I won't draw those connections, only the corresponding letters. Now, I want different configurations. So 1, the signal through the delay, 2, through the distortion, 3, going into distortion and then distort the signal into the delay. 4 going both to delay and distortion in parallel. That means the clear signal goes to the delay and a copy of this clean signal goes through the distortion. The effects, they don't interact with each other. Let's draw the wiring now. First position, only delay. So let's connect the input of the inner lug A, the one connected to the mic, to the input of the delay board. And then the output of the delay board, which remember is connected to inner lug B, is connected to the output jack. Very good so far. Output of the distortion board isn't connected to anything. Now, the signal to go only through distortion. So we select the next position, and as you can see, each inner lug is now connected to its outer lug number 2. So the signal, still coming from A, goes to distortion board's inputs, and the output of the distortion, which goes to inner lug C, has to be connected to the output jack. But no need to connect another wire all the way to the jack. Instead, let's connect the lug C2 to lug B1, which is already connected to the output. When in first position, the B1 lug will be connected to C2 lug. But since this C2 is connected to nothing in this case, that won't be a problem. So we check the mic signal is connected to the distortion and the distortion signal goes to the output jack. Perfect. For the third position, signal has to go through the distortion and then through the delay. So same process. A3 has to be connected to the input of the distortion, but let's connect it directly to lug A2 since it is already connected to distortion, but distortion signal has to feed the delay now. So lug 3 is connected to delay in. But once again it is shorter to connect it to A1, which already has a wire going to delay in. See, all lugs are grouped there, and believe me, the less wire you have, the less mess you get. Position 4, the signal feeds the two effect boards in parallel. A4 goes to distortion, so we connect it to A3, but it also has to go to the delay, so we connect it to A1, and we will send the delay out to... Oh, I realized I forgot a connection in position 3. Delay output needs to be sent to jack socket, so let's do that and connect B3 directly to B1, and we're set. And since in position 4 delay also goes to output, let's connect it to B3. Also, don't forget that distortion in this case also has to go to the main output, so let's connect C4 to C2, which as you can see is connected to the output as well. Now we have more connections made, so we need to check if the signal isn't going where it's not supposed to, and for that we need a diode, which kind of works like a one-way switch. It allows current to flow in one direction, but not the other way around. It's kind of it. It's more like severely restricted, and that will do for my projects, I guess. Final check. Position 1, signal going to delay, but also to A4, A3, A2, and distortion that we do not want. So let's implement a diode right here. So signal cannot go from A1 to distortion, but will flow from A4 to delay. B1 to output, okay. B3 and 4 not connected. C2 and 4 same. Okay. Position 2, A2 to distortion, okay. A3, A4, alright, but also going to delay, which is not what we want. So we put a diode there between A2 and A3, so no signal can come from A2. C2 goes to C4 and B1, 3, 4, not connected. Okay, but also goes to output, which is supposed to, so alright. Position 3 to distortion and then to delay. So A3 from the mic is going to distortion, okay, and into the delay. Oh, I made a mistake. This diode here should move to there. It's weird, I didn't notice that at first, but okay. I kind of correct it. From the delay, B3 goes to B4, which is not connected, like C2 and C4, but it goes to the output. Okay, correct. V3 coming from the distortion goes into the delay and cannot go to A4 thanks to the diode. Perfect. Position 4 to distortion and delay in parallel. So A4 going to delay, okay, going to distortion, right. B4 from the delay is going out, okay, and also going to C2 and C4 the distortion output? No. Okay. Let's get some help from a diode once again. Signal can't go that way. Great. Now C4 going to output. Okay. And oh no, not to leg B4. So let's implement a last diode there, right? No, the other way around. Otherwise it's useless. Here will be even better. Well, it's all checked out, so let's connect everything in real life and test if what I imagined is working correctly.
We're gonna modify this PT2399 Eco to get extra controls over time and feedback. I got all information about it from a video by Mike Sisk, there's a link in the description below. We need a few pots, a small resistor and some wires. First, remove that R27 resistor and the onboard potentiometer if you want. You can solder the B50K instead. Connect the B100K here with a 1 or 2K resistor in series and pay attention to that C15 capacitor. On this tiny leg, we have to solder a wire. That wire will be connected to the A100K. Then, of course, the 9 volts, the input and the output, and the ground. Now we have a mixed knob plus time and feedback. I didn't film everything. If you want to go deeper into soldering, check Mike's video. Soldering is over. Let's check how that sounds.
ça.